Square roots. The square root of a number is the part of a number that when multiplied by itself equals the number. It's easy to think of square roots as the opposite of squaring. We know that 4 squared equals 16. The opposite of squaring is square root. What number times itself gives me 16? That answer would be 4. So squaring and square rooting are like plus and minus. They're opposites. Let's look at the square root of 49. What number times itself equals 49? If we have our multiplication tables memorized, we know that answer would be 7. The symbol you see here above the 49 and the 16 is called the square root symbol. We use that to show square root. We're now going to go through our square roots, ones you should have memorized, because if you have your multiplication tables memorized, these will come easy. The square root of 1 equals 1. We know that because 1 squared equals 1. The square root of 4 equals 2 because 2 squared equals 4. The square root of 9 equals 3 because 3 squared equals 9. These are opposites of each other, and at this point you should see a pattern developing. The square root of 16 equals 4 because 4 squared equals 16. The square root of 25 equals 5 because 5 squared equals 25. The square root of 36 equals 6 because 6 squared equals 36. Remember, squared 6 times 6. Continuing down, and these are the ones you should memorize, the square root of 49 equals 7 because 7 squared equals 49. And the square root of 64 equals 8 because 8 squared equals 64. The square root of 81 equals 9 because 9 squared equals 81. The square root of 100 equals 10 because 10 squared equals 100. The square root of 121 equals 11 because 11 squared equals 121. And the square root of 144 equals 12 because 12 squared equals 144. If you have your multiplication tables memorized, 1 times 1, 2 times 2, 3 times 3, 4 times 4, all the way down to 12 times 12, then these should be easy for you. These numbers here, our answers here that appear under the square root symbol, are perfect squares. Okay, because we can find a square root for them. So take some time, do some memorizing, and we'll continue. Sometimes the square root of a number does not come out to be a whole number. In these cases, we need to estimate the square root. Let's look at an example, the square root of 42. If we tried to find what number times itself equals 42, we would never be able to find the answer. If you don't believe me, stop the tape and use your calculator now. You will never find a number times itself that equals 42. So we have to estimate what is it in between. We know our square roots that we had up before, that the square root of 36 is 6. We know that the square root of 49 is 7. 6 times 6 is 36. 7 times 7 is 49. When we look at the square root of 42, most people immediately want to say 21. But 21 times 21 is not 42. So don't make that mistake. Let's look at the square root of 42, which comes in between the square root of 36 and the square root of 49. 36, 42, 49. Those are in numerical order now. So that means the square root comes between 6 and 7. If 42 was closer to 36 than 49, we could say the square root of 42 is closer to 6. If it was closer to 49, we could say it's closer to 7. But 42 is almost midway between 36 and 49. It's 6 away here, and it's 7 away there. So we could say that the square root of 42 is approximately 6 1/2. Either way, between 6 and 7, or approximately 6 1/2 would be fine. If your calculator has a square root button, you can find a more approximate answer, but you will still need to round it off.
Please pause the video now and complete the problems in your workbook. When finished, press play, and we'll continue with the next lesson.